It did. I have the video. I sent it to Elon that night. I was like, hey man, here's the video from 5 minutes ago. It worked.
More than 2 years after the first deliveries began in late 2023, the Cybertruck has now entered the 2026 model year. There are growing rumors within the industry suggesting that Tesla could introduce a compact pickup truck as early as 2026, following remarks reportedly made by Chief Engineer Lars Moravy that bring a series of major upgrades in features, technology, design, and a revised pricing strategy. From PowerShare integration with Powerwall, an initial image of the new compact variant, to significantly improved charging performance, requiring just 43 minutes at Tesla supercharger stations, this vehicle is being elevated to an entirely new level of engineering excellence. While as many as 98% of people tend to judge the Cybertruck purely by its exterior appearance, what is truly astonishing lies beneath the surface, where Tesla has achieved a remarkable leap forward in engineering and technology. One more especially notable as Tesla is widely believed to be preparing the launch of 4 distinct high-performance variants of its new 4680 battery in early 2026. So, what truly sets the 2026 Tesla Cybertruck apart? Why is Tesla confident that the Cybertruck will drive a major surge in sales in 2026? Welcome to Tesla Car World. For automotive enthusiasts, it's no secret that the uniqueness of the Cybertruck goes far beyond its exterior design. Instead, it is the result of a sophisticated integration of 5 core elements that Tesla has meticulously researched, engineered, and assembled with precision. However, the reality is that 2025 has been a challenging year for this model, as it has experienced a significant decline in sales. Despite being engineered with advanced technology and impressive performance, the electric pickup has fallen short of the ambitious targets originally set by CEO Elon Musk. Growing evidence suggests that the Cybertruck is shifting from a must-have product to a niche offering within the commercial electric pickup segment. The data speaks for itself. Cybertruck sales in 2025 dropped sharply compared to expectations. Even when including the fourth quarter of 2025, Tesla is estimated to have sold only around 17,000 to 19,000 units, far below the annual target of 250,000 units that Elon Musk projected back in 2023. For comparison, in 2024, the first year of full-scale sales, the Cybertruck sold 38,965 units, making it the best-selling electric pickup truck in the United States. However, in the first quarter 2025, it lost that position to the Ford F-150 Lightning, marking a significant turning point. Alongside these sales fluctuations, the Cybertruck has also faced a series of quality and safety-related issues, raising concerns among owners. As of October 2025, the model has undergone more than 10 separate recall campaigns, ranging from critical defects to moderate-level issues. The most serious among them involves the cant rail, the decorative metal trim located above the windshield, which may lose adhesion and detach while the vehicle is in motion, posing a potential hazard to surrounding traffic. This issue alone has affected 46,096 vehicles and generated approximately 150 customer complaints, although Tesla has stated that no accidents related to this defect have been reported to date. In addition, the Cybertruck has encountered several other notable issues, including inverter failures that can cause sudden power loss, a tire pressure monitoring system that fails to display warnings, off-road lights that may detach, underperforming windshield wipers, and an accelerator pedal that has the potential to become stuck. While not all of these problems are classified as high severity, the succession of recall campaigns has negatively impacted consumer confidence and helps explain the Cybertruck's slowdown in the market. However, looking ahead to 2026, the Tesla Cybertruck may be poised for a significant resurgence. In several major markets such as South Korea and China, the Cybertruck has already been among the first vehicles to receive full self-driving version 14 updates. These capabilities are considered comparable to the level of autonomy currently demonstrated by Tesla's Robotaxi platform. In addition, according to Doug DeMuro, a well-known automotive reviewer and the founder of the Cars and Bids auction platform, the Tesla Cybertruck is likely to drop to a price point of around $35,000 within the next 18 months. Speaking on his personal podcast, DeMuro noted that he has already seen Cybertrucks trading at prices above $60,000 and that they are rapidly approaching the $50,000 mark. As the operator of Cars and Bids and a seasoned observer of automotive market dynamics, particularly the real-world pricing of heavily hyped vehicles. He pointed out that while models such as the Hummer EV and Rivian R1T have also experienced significant depreciation, the Cybertruck's price decline appears to be even steeper. All of this signals the emergence of a major price correction, one that stands to deliver substantial benefits to end consumers. Honestly speaking, pricing has always been a major concern for consumers. The Cybertruck is currently priced at approximately $79,999 for the rear-wheel drive version, rising to around $88,000 for the extended range configuration. The Cyberbeast variant, capable of accelerating from 0 to 60 miles per hour in just 2.6 seconds, carries a price tag of roughly $100,000. Notably, the Cybertruck's turning radius is only about 17.5 feet, compared to roughly 23 feet, for a typical, full-size pickup truck. By the end of 2025, Tesla had implemented systemic changes to its GigaCasting technology in an effort to resolve long-standing bottlenecks in Cybertruck assembly. Rather than making incremental, localized adjustments, the company overhauled its entire large-scale casting methodology to simultaneously address both production throughput and build quality. Technical evidence from the production lines at Gigafactory Texas indicates that Tesla has transitioned to a new generation casting mold, engineered with integrated mounting points for the suspension system and electrical wiring. As a result, the number of discrete components in the rear structure has been dramatically reduced, from approximately 80 individual parts to a single, fully integrated casting. This structural simplification not only streamlines the assembly process, but also significantly lowers the risk of misalignment and finishing defects. Manufacturing efficiency improved noticeably soon after these changes were implemented. The operating cycle of the 9,000-ton GigaPress was shortened by approximately 15 to 20%, enabling a significant increase in chassis output within the same time frame. Drone footage captured at Gigafactory Texas in November 2025 revealed a much higher density of finished cast frames in storage yards compared to earlier in the year, directly reflecting the accelerated pace of production. These manufacturing improvements directly laid the groundwork for sales performance in the third quarter 2025. After completing deliveries of the Foundation series to early reservation holders, Tesla began accelerating Cybertruck distribution to the broader market. According to official production and delivery reports released in October 2025, Tesla delivered a total of 15,933 vehicles under the Other Models category, which includes the Model S, Model X, and Cybertruck. While the figures were not broken out individually, market analysts estimate that the Cybertruck accounted for more than 5,000 units of that total, an indication that real-world demand had stabilized compared to the initial launch phase. Geographically, Tesla had largely cleared its U.S. order backlog and began ramping up deliveries in Mexico and Canada toward the end of 2024. This was widely viewed as a critical stepping stone as the company prepared for broader global expansion. By early 2026, the Cybertruck's international ambitions became increasingly evident, as prototype vehicles were spotted undergoing regulatory and safety compliance testing in both Europe and China. When discussing the Cybertruck, many people tend to focus on its rugged exterior and even feel tempted to test its impact resistance. However, another highly noteworthy aspect of the exoskeleton is that Tesla has created the largest one-piece door ring structure in the world. The entire outer frame is constructed from high-strength boron steel, with the inner and outer structures welded together into a single unified component, forming an exceptionally rigid B-pillar. The Cybertruck also makes extensive use of large-scale castings. The front casting is produced using a 6,500-ton press, while the rear casting is formed with a press rated at up to 9,000 tons. Tesla has confirmed that 4 casting machines are currently operating at full capacity, producing approximately 5,000 castings per day, an extraordinarily impressive figure. These castings are further nickel-plated to enhance durability, corrosion resistance, oxidation resistance, and heat tolerance. The Cybertruck's structure is engineered to absorb impact forces in rear-end collisions at speeds of around 50 miles per hour. It supports a payload capacity of up to 2,500 pounds and a towing capacity of up to 11,000 pounds, all built around the exoskeleton framework. In the event of a severe crash, the front underbody casting is designed to fracture into multiple smaller sections, helping to dissipate and absorb energy while reducing the force transmitted to occupants. However, this approach also implies potentially high repair costs, as these large cast components are expensive to replace. The primary objective of gigacasting technology is to replace numerous welded and bolted parts with a single integrated structure, simplifying manufacturing and reducing upfront production costs. That said, a key trade-off is the potentially higher cost of repairs following major collisions. The Cybertruck is equipped with a fourth-generation inverter, similar to that used in the Model Y Performance. Leveraging silicon carbide semiconductor technology, this inverter delivers higher efficiency, greater power density, and lower energy losses. Its higher switching frequency reduces overall losses by approximately 50% while producing a smoother alternating current for the electric motors. The Cybertruck operates on an 800-volt electrical architecture, yet it retains flexible charging capability at both 400 volts and 800 volts by splitting the battery pack into two separate 400-volt sections. The vehicle also supports bi-directional power output of up to 11.5 kilowatts, enough to supply electricity to an average home for approximately 3 days during a power outage. Another standout feature is the steer-by-wire system, previously introduced on the Model S and now deployed on the Cybertruck. This system utilizes two independent 48-volt electric motors, providing built-in redundancy. Even if one motor or controller fails, the vehicle can continue operating safely using the remaining unit. In addition, the Cybertruck features rear-wheel steering with a steering angle of approximately 10 degrees, significantly improving maneuverability at low speeds. From a design standpoint, Tesla began by asking a fundamental question: what should a Tesla pickup truck look like? After conducting market research, the company observed that traditional pickup trucks have remained largely unchanged for decades, almost all relying on a body-on-frame construction. Tesla chose a completely different path, creating an exoskeleton in which the exterior shell itself serves as the primary load-bearing structure. Thanks to this architecture, the Cybertruck requires far fewer internal reinforcements, such as pillars, ribs, or subframes. The entire rigid stainless steel outer shell carries structural loads, delivering exceptional durability in off-road conditions. Tesla uses a specialized stainless steel alloy known as 30 times, often referred to as hard stainless steel, characterized by flat surfaces and minimal curvature, which give the vehicle its distinctive futuristic appearance. The sharp edges are rounded during the manufacturing process to ensure safety during contact. The transition from a traditional 12-volt system to a 48-volt architecture reduces electrical current to just 1/4 of previous levels, which in turn lowers wiring weight, improves efficiency, and reduces costs. Tesla has also moved to a gigabit-speed Ethernet communication system, dramatically cutting down the amount of wiring throughout the vehicle. Overall, wiring length has been reduced by up to 68%, while the mass of high-power cables has been reduced by as much as 84%. Adopting a 48-volt architecture gives Tesla a significant advantage in developing accessories such as lighting systems, winches, and air compressors, all of which are purpose-built for the Cybertruck. This approach not only enhances the customer experience but also opens up new revenue streams for Tesla. Why did Tesla need to develop 4 versions of the 4680 battery? What was their purpose? Tesla's decision to equip the Cybertruck with its proprietary 4680 battery cells, measuring 46 mm by 80 mm, represents one of the company's most ambitious technological bets. First unveiled in 2020, the 4680 platform was designed to simultaneously reduce manufacturing costs and extend driving range by rethinking cell form factor, chemistry, and structural integration. Yet despite its promise, the rollout of this technology has faced substantial challenges, particularly in scaling production and achieving consistent performance. As a result, the 4680 battery remains exclusive to the Cybertruck, while other Tesla models such as the Model 3 and Model Y continue to rely on proven 2170 and LFP battery formats. What is now emerging, however, suggests a major turning point. In early 2026, Tesla is expected to introduce 4 distinct variants of the 4680 cell, each optimized for a specific use case. The NC05 variant is reportedly tailored for Tesla's Robotaxi platform, prioritizing durability and lifecycle efficiency. The NC20 version targets the Cybertruck and future SUVs, offering higher energy density for improved range and performance. Meanwhile, the NC30 and NC50 variants are expected to incorporate silicon carbon anodes, significantly lowering costs while maintaining competitive performance. Together, These developments point to a long-anticipated breakthrough, one that could finally unlock the full potential of Tesla's 4680 battery strategy. In the high-stakes arena of electric vehicle manufacturing, Tesla's ambitious push for 4 distinct variants of its groundbreaking 4680 battery cell, NC05, NC20, NC30, and NC50, represents not just technical evolution, but a calculated master stroke to reclaim American leadership in global battery production, slash costs for U.S. consumers, and outmaneuver foreign competitors like China's BYD and KTL. Unveiled at Battery Day in 2020, the 4680 cell was Tesla's bid to revolutionize cylindrical batteries. 5 times the energy capacity, 16% higher range, and up to 56% lower production costs compared to the incumbent 2170 cells still powering Model 3 and Model Y. Yet, implementation has been rocky. Currently exclusive to Cybertruck production at GigaTexas, the 4680 faces yield rates as low as 20 to 30%, with cathode scrap losses hitting 70 to 80% during trials, versus under 2% for traditional wet process rivals, due to the revolutionary dry electrode coating that eliminates costly solvents and baking steps. This manufacturing gauntlet explains the imperative for 4 tailored variants, each optimized for specific vehicle architectures, performance profiles, and price points, ensuring Tesla can scale to millions of units annually by 2026 without compromising on affordability or reliability. The NC05 emerges as the workhorse cell, prioritizing durability and longevity for fleet-heavy applications like the upcoming Robotaxi Cybertruck and Tesla Semi. Insiders describe it as rugged enough for high-cycle operations. Think 1 million miles in autonomous Robotaxis, leveraging dry-coated cathodes for cost savings while maintaining baseline energy density. For American rideshare drivers and logistics firms, weary of gas-guzzling fleets amid $4 per gallon prices, NC05 promises unbreakable uptime, directly challenging Uber and UPS's hesitation on EVs. Next, the NC20 steps up with enhanced energy density, targeting Cybertruck dual-motor variants, next-gen SUVs, potentially a $30,000 compact crossover, and broader lineup integration. This variant addresses Cybertruck's Achilles heel. Its current 320 to 340-mile range lags rivals like Rivian R1T's 410 miles, partly due to immature 4680 scaling. By boosting watt-hour per kilogram through refined dry processes, NC20 enables Tesla to hit over 400-mile ranges without oversized packs, critical for U.S. truck buyers in flyover states where charging deserts persist. Data from Tesla's the third quarter 2025 earnings hints at NC20 trials yielding 10 to 15% better efficiency, positioning Cybertruck as a viable F-150 Lightning killer. So with Cybertruck sales falling far short of Elon Musk's original projections, does this signal a misreading of American truck buyers or a temporary setback before a 2026 comeback? Please share your opinion in the comments section below this video. Thanks for watching our video. Subscribe now so you don't miss the next breaking Tesla update. If you want to explore more exciting information about Tesla EV or Tesla Bot, don't forget to hit the like button and share this video.
We look forward to unveiling Optimus V3, probably in Q1. I think it'll be ready to show off. That I think is going to be quite remarkable. It won't even seem like a robot. It'll seem like a person in a robot suit, which is kind of how we started off with Optimus. But it'll seem so real that you'll need to poke it, I think, to believe that it's actually a robot.
Sounds great, but it's clear that the world still doesn't fully trust the idea of humanoid robots. More accurately, most people simply don't believe anything could surpass human dexterity, let alone those clunky machines that walk around like they're wearing diapers. Okay, to be honest, nothing else in the world is smarter than humans. Nothing can truly replace us, much less dominate us. Yet Elon Musk continues to pour billions of dollars into this project because he believes Tesla can build a robot with a brain, arms, and legs that truly resemble those of a human being. Alright, at this point, the Terminator scenario probably pops right into your mind, right? But what if we had a humanoid robot that could actually help us? A robot like a personal assistant that serves beer, makes your morning sandwich, and cleans the entire house? We'd all love to have a companion like that. And that's exactly what we'll start seeing next year with the Tesla Bot Gen 3, Elon Musk's newest generation humanoid robot. if you're sick and tired of boring, repetitive household chores. The Tesla Bot Gen 3 is something you'll want to buy next year. It's set to be the world's first robot capable of cooking, cleaning, and even opening your fridge to grab you a beer. As Elon Musk has emphasized several times that Optimus could help teach children, clean your house, mow the lawn, walk the dog, babysit, and also enable the production of goods and services. Above all, Elon Musk has openly acknowledged that AI and robots will replace all jobs. Working will be optional, like growing your own vegetables instead of buying them from the store. Optimus will ultimately be better than the best human surgeon, with a level of precision that isn't possible, that is beyond human. So how would the Tesla Bot Gen 3 actually function in a surgical room? And can we really trust a machine to make critical decisions in emergencies during surgery, like controlling bleeding or handling unexpected complications? Welcome to Tesla Car World. While the excitement around Tesla Bot Gen 2 hasn't died down yet, Elon Musk has confirmed that Optimus Gen 3 will debut in the first quarter next year. This version will be capable of doing everything from cooking and cleaning to taking care of people. Yeah, according to Musk, it will be so human-like that we'll have a hard time telling the difference, and it will be able to perform around 3,000 useful tasks at a price of $30,000. Even before Optimus Gen 3 is released, Elon Musk has shocked everyone by announcing that Tesla will mass-produce Optimus Gen 4 and Gen 5. This means that Optimus Gen 3 won't be the final version of the Tesla bot. And if the Gen 3 model can perform 3,000 useful tasks, that implies Optimus Gen 5 could double that number to around 6,000 tasks, with accuracy potentially matching that of a human. It won't just be limited to simple chores like cooking and cleaning. It will also be integrated into various environments, one of which is hospitals. According to Elon Musk, Optimus Gen 5 could even perform surgeries with extremely high precision. According to speculation, this could be the most advanced and expensive version of the Tesla bot. We wouldn't be surprised if it's priced around $80,000. The logic is simple. If it can handle 70 out of the 100 tasks a human can do, it could actually generate income for its owner. In that sense, it would pay for itself, and the payback period could be quite short. Tesla aims to produce around 10 million units of the upcoming Gen 4 model, and as many as 100 million for Gen 5. Most people understandably find that hard to believe, and honestly, so do we. Still, if Optimus 3 delivers on even half of what's been teased, we're about to witness one of the most extraordinary leaps in robotics yet. Optimus probably achieves 5 times the productivity of a person per year because it can operate 24 hours per 7 days. It doesn't even need to charge. It can operate tethered. So it's plugged in the whole time. However, it seems Tesla may be running a bit behind on Optimus 3. The robot was originally expected to make its big debut at the company's major November event, but that's now been pushed to the first quarter of next year. The delay likely comes down to one key challenge: the hands. During the meeting, Musk openly acknowledged the hurdles his team is facing. He called bringing Optimus to market an extremely difficult task, and even admitted that the robot's hands and forearms are proving to be a tougher engineering problem than the rest of the entire machine combined. As we've mentioned before, and as Elon Musk has repeatedly emphasized, the hands are by far the most complex and expensive part of Optimus. If each unit costs around $50,000, Musk estimates that the hand technology alone could account for half, or even 60%, of that total. To make Optimus 3's hands move and function like a human's, Tesla needs to replicate the intricate anatomy of 4 fingers and a thumb, each with multiple joints, different lengths, and a muscle-like system built into the forearm. Building a robotic hand that can gently hold an egg, thread a needle, or lift a dumbbell isn't just difficult. It's one of the toughest mechanical challenges in robotics. It demands compact actuators that are both powerful and incredibly precise. Beyond the hands, another major challenge lies in mass production. During the earnings call, Musk revealed Tesla's ambitious goal to eventually build 1 million Optimus robots per year. Then he highlighted a sobering truth. There is no supply chain for humanoid robots. Okay, that means Tesla must create nearly every key component in-house, from actuators to control systems, pushing vertical integration to unprecedented levels. It's a massive undertaking, one that only a company with Tesla's scale and manufacturing expertise could realistically attempt. How will Tesla Bot Gen 3 convince people to accept AI by doing household chores? Right now, Tesla's focus remains on something far more practical: household chores. This stage of development might seem modest compared to the robot's long-term ambitions in factories or even Mars colonies, but it's a crucial first step. Elon Musk understands that for the public to truly accept humanoid robots, Optimus must first prove itself useful in daily life. A robot that can tidy the living room, fold laundry, or prepare a simple meal will have a much easier time earning the trust and curiosity of customers than one performing complex industrial tasks that feel distant from everyday reality. For decades, when people imagined robots and artificial intelligence, the images came straight out of science fiction. Gleaming androids from movies, like iRobot walking, talking, and serving breakfast in futuristic kitchens. But in the real world, that dream felt impossibly far away. The idea of a machine casually standing in your kitchen, making a sandwich, or reaching into the fridge for a drink seemed almost absurd. After all, cooking and cleaning aren't just about strength. They require finesse, adaptability, and the delicate control of human hands. Things that even the most advanced machines have long struggled to replicate. That's where the Tesla Bot Gen 3 breaks new ground. Tesla has designed Optimus with a level of anatomical precision that borders on human. The human hand, with its 27 joints and intricate network of tendons and muscles, is capable of both strength and subtlety. From holding a heavy pan to threading a tiny needle. To mimic this, Tesla has engineered dozens of miniature actuators inside each robotic hand, allowing for up to 22 degrees of freedom. In simple terms, each finger can move, bend, and react, almost like a real one. It's not just engineering, it's biomechanics brought to life. And while the day Optimus casually flips pancakes in your kitchen may still be a few years away, the technology being developed today is what will make that once impossible scene a reality. It's precisely because of this highly sophisticated hand design that Optimus can perform delicate tasks that once seemed impossible for robots. It can gently cradle an egg without breaking it, slice a tomato into paper-thin pieces without crushing it, and spread mayonnaise with just the right amount of pressure, a level of control that blurs the line between machine and human. Most robotics companies, like Unitree or Boston Dynamics, have mastered agility. Their robots can run, jump, or even dance. But they still can't peel an orange. The difference lies not in strength, but in fine motor control and cognitive understanding, areas where Tesla has taken the lead. For over a year now, Optimus has been training 16 hours a day at Tesla's research facility in Palo Alto, California. What makes this process revolutionary is how it learns. Instead of being programmed line by line like traditional robots, Optimus learns autonomously through a sim-to-real method, the same way humans learn through observation and practice. It can watch tutorial videos, observe a human making a sandwich or cleaning a table, and then simulate the process in a virtual environment. Within that simulation, it makes mistakes, analyzes them, and gradually improves until it achieves near-perfect performance. This continuous learning loop allows Optimus Gen 3 to master new tasks every single day, whether it's preparing breakfast, setting the table, or organizing a messy kitchen. According to Elon Musk, the next version of Optimus will feature major hardware and mobility upgrades, giving it faster reflexes, more natural walking movements, and better balance across uneven terrain. While today's prototype still moves cautiously, Musk promises that by the time Optimus is ready for commercial release, it will walk, move, and react like a human. And most impressively, it will almost never fall down. Thanks to its advanced perception systems, it can interpret not only voice instructions, but also facial expressions and body language. Imagine standing in your kitchen after dinner. You don't even need to say a word. A simple glance toward a pile of dirty dishes or a quick point of your finger is enough for Optimus to recognize what you want. Within seconds, it will calmly approach the sink, roll up its digital sleeves, and start cleaning. This ability to read nonverbal cues makes interaction with Optimus feel far more natural, almost like communicating with another person rather than a machine. The secret behind this lies in the AI-5 cognitive system that powers the Tesla Bot Gen 3. This next-generation neural architecture allows Optimus to build its own navigation maps and adapt dynamically to different home environments. Every house is unique, from narrow hallways and uneven floors to cluttered living rooms and playful pets darting around. Using its onboard cameras, depth sensors, and real-time processing unit, Optimus constantly scans its surroundings, creating a three-dimensional layout of the home. It remembers where the furniture is, knows which rooms are connected, and can move effortlessly between them without bumping into anything. Even more impressively, Optimus's AI system is context-aware. It can distinguish between a chair and a sleeping pet, a dropped toy and a power cord, and adjust its movements accordingly. If a child suddenly runs across the room or a dog wags its tail near its feet, Optimus instantly recalculates its path, maintaining both safety and efficiency. This situational intelligence represents a leap forward from earlier robots that relied on rigid, pre-programmed routes. Instead of merely following commands, Optimus interprets intentions, combining human cues, environmental data, and predictive reasoning to act with precision and empathy. It's not just automation. It's the beginning of true coexistence between humans and intelligent machines in everyday life. Why can Tesla Bot Gen 3 potentially change the labor market? Priced at under $20,000, Optimus could earn its owner around $2,000 per month performing various labor tasks. That means the robot could pay for itself in less than a year and continue generating profit for many years after that. Unlike human workers, Optimus doesn't require rest, food, or payment beyond the initial purchase. It never gets tired, doesn't need health insurance, and doesn't complain, which makes it an ideal worker and a highly attractive investment for businesses and individuals alike. Elon Musk has focused public attention on Optimus's domestic abilities, but the real story lies in its potential to become a universal labor force. Imagine a small business owner running a restaurant. One robot takes orders, another cooks, a third serves food, and a fourth cleans up. While the initial cost of purchasing several units might seem high, the return on investment would come quickly once the robots start replacing human workers. Within months, a restaurant could recover its investment and then operate almost entirely on automated labor, dramatically reducing costs and increasing efficiency. Beyond restaurants, Optimus can be deployed in factories, warehouses, hospitals, retail stores, and even homes as a rental worker. A new business model could soon emerge where individuals buy Optimus units and lease them to other companies or households, creating a passive income stream similar to Tesla's upcoming robotaxi network. Owners could register their robots on a shared platform, allowing Optimus to work during idle hours and generate revenue autonomously. Financial analysts have already begun calculating the scale of this opportunity. According to Adam Jonas from Morgan Stanley, if one humanoid robot working at $5 per hour can replace two human workers earning $25 per hour, then each robot could create a net present value of roughly $200,000. This figure turns the $30,000 robot into an investment asset capable of delivering 10 times its initial cost and value. If Tesla succeeds in scaling Optimus production and integrating it into the labor economy, the company will not only sell robots, but will also create an entirely new economic system built on artificial intelligence, robotics, and clean energy. Optimus thus represents the beginning of a new era in which machines generate wealth alongside humans. In healthcare, for instance, Optimus could play an instrumental role as an assistant nurse or caregiver. Equipped with sensors, cameras, and real-time data analysis, the robot can monitor vital signs, deliver medication, assist patients in moving, and alert staff to potential health risks. As populations age and labor shortages worsen, especially in countries like Japan, Germany, and the United States, healthcare systems are under immense pressure. Robots like Optimus can help fill these gaps by performing repetitive and physically demanding tasks, freeing up human nurses and doctors for higher-level responsibilities. This application not only saves hospitals operational costs, but could also bring in revenue by allowing them to serve more patients efficiently. Beyond healthcare, Optimus has immense potential in security and surveillance. Thanks to its full-body network of cameras and sensors, it can perceive its surroundings in 360 degrees, detect suspicious activity, recognize faces, and respond instantly. Unlike static security cameras, Optimus can move, patrol, and even intervene when needed. It can alert homeowners via smartphone, trigger alarms, or record incidents as evidence. For businesses, replacing security guards with Optimus units means continuous protection without recurring salaries. In financial terms, this transforms a traditional expense into a long-term investment that continues to deliver value around the clock. The industrial potential of Optimus is equally significant. Tesla has already demonstrated the robot's ability to recognize car parts, pick them up, and place them precisely in designated locations. This seemingly simple act requires complex coordination between visual recognition, spatial mapping, and mechanical control, skills equivalent to those of a trained factory worker. Unlike traditional industrial robots limited to repetitive, pre-programmed tasks, Optimus is flexible and mobile. It can move across the factory floor, retrieve parts, deliver them to assembly stations, and even adjust its behavior through AI learning. Economically, Optimus could trigger a paradigm shift. As humanoid robots become affordable and productive, ownership of labor itself could decentralize. Just as individuals today own cars or rental properties, people in the near future may own robots that work and earn money for them. This could give rise to a new robotic labor economy, where wealth is generated not only by human effort, but also by autonomous machines operating continuously. With Optimus, new professions will emerge: robot trainers, AI programmers, maintenance engineers, human-robot interaction designers, and network supervisors overseeing robot fleets. Human labor will shift from physical tasks to creative, strategic, and emotional work that machines cannot replicate. So, if robots take over most hard labor, how will we care for and protect the people who lose their jobs? Please share your opinion in the comments section below this video. Thanks for watching our video. Subscribe now so you don't miss the next breaking Tesla update. It's coming in just 2 days. If you want to explore more exciting information about Tesla EV or Tesla Bot, don't forget to hit the like button and share this video. Also, make sure to turn on notifications so you never miss our latest videos.
Now this battery brings in our latest and greatest in terms of technology. It is cheaper to manufacture, and the best part is that it's actually less battery energy than in our current pilot production vehicles. But it maintains the same range. This is achieved through efficiency improvements that we're showing here, more than 7% at this point.
Tesla Semi is entering a critical transition phase, moving from limited pilot production to full-scale mass production. After 8 years of development, the company plans to begin online production at the Giga Nevada factory in the first quarter 2026, aiming to achieve real output, targeting 50,000 vehicles per year, equivalent to just over 4,000 vehicles per month, once the 1.7 million square foot Tesla Semi facility is fully operational. For the first time, Tesla will employ the massive GigaPress for the Semi line. This technology allows the production of large chassis components in just a few minutes, significantly accelerating manufacturing speed, with a goal of rolling out 1 truck every few minutes. Particularly the transition to next-generation 4680 cells, promising a 20% reduction in battery weight while maintaining a 500-mile range. Real-world production data from DHL and ArcBest show an energy efficiency of 1.55 kilowatt-hour per mile under full load, confirming the vehicle's practical potential to compete directly with diesel trucks on economic performance metrics. In today's episode, we'll explore 4 key topics: the detailed Tesla Semi production schedule for 2026, the evolution of battery technology from LFP to the latest 4680 cells used in the Tesla Semi Gen 2, the design upgrades in the Gen 2 Tesla Semi, and how partners like DHL and ArcBest have verified the energy efficiency achieved by the Tesla Semi under real-world operating conditions. Welcome to Tesla Car World. By the way, we've just updated the latest information on Tesla Semi's pricing policy for 2026. Honestly, it's truly different and has sent shockwaves through the heavy-duty electric truck market when compared to the Freightliner e-Cascadia or Volvo VNR Electric. If you want us to dive deeper into this gap, hit the like button to let us know so we can continue researching it in more detail. Thank you. Back to today's topic. What does the detailed Tesla Semi production schedule for 2026 look like? Tesla's updated production roadmap for the Semi in 2026 is far more credible than its earlier timelines because, for the first time, it is underpinned by visible construction progress, committed capital, and a maturing battery supply chain rather than slide deck promises. According to Tesla's the third quarter 2025 updates, the company expects the first online builds from its new dedicated Semi factory in Nevada to roll off the line in the first quarter 2026, with a structured ramp through the second quarter and true volume production in the second half of 2026, targeting an annualized rate of 50,000 units. This sequence, pilot builds, controlled ramp, then volume, is consistent with how Tesla has scaled previous platforms such as the Model 3 and Model Y, where early quarters focused on learning and debugging the line before throughput rose sharply. The fact that Tesla is explicitly distinguishing between online builds and real production suggests a disciplined, automotive-grade industrialization path rather than a marketing-driven announcement. The 2026 Tesla semi-production schedule is backed by tangible progress and major investments already in place. Tesla's 1.5 million square foot semi-facility at Giga, Nevada is essentially complete, with equipment installation underway, as confirmed in May 2025. Part of a $3.6 billion investment, the site includes a dedicated 100 gigawatt-hour 4680 battery plant to secure cell supply, previously the program's main bottleneck. This marks a shift from years of delays since the Semi's 2017 debut, during which only about 300 units were built. Unlike earlier low-volume validation runs, Tesla now has a dedicated factory, secured batteries, and clear executive commitment to scaling production. Furthermore, the 50,000 units per year target in the second half of 2026, while ambitious, aligns with the scale of demand and regulatory pressure facing the heavy-duty trucking market. Major fleets in North America, including PepsiCo, Walmart, and UPS, have placed reservations or expressed interest in zero-emission Class 8 trucks to meet corporate decarbonization targets and comply with increasingly stringent state-level rules, such as California's Advanced Clean Trucks and Advanced Clean Fleets regulations. These policies will gradually force a shift away from diesel, creating a structural incentive for manufacturers that can deliver electric trucks at scale. So how does the transition from LFP to 4680 batteries transform the Tesla Semi Gen 2? Tesla's evolving battery strategy for the Semi directly underpins the credibility of its 2026 mass production plan, because it shows a clear transition from constrained multi-supplier pilot chemistry to a unified vertically integrated 4680 platform sized for heavy-duty use. From 2022 to 2025, Tesla effectively treated the Semi as a low-volume, semi-experimental program, splitting chemistries by use case. Lithium iron phosphate packs of around 500 kilowatt-hour for the shorter-range 300-mile variant and higher-energy nickel-based chemistries in the 800 to 900 kilowatt-hour range for the 500-mile version. This dual approach allowed Tesla to validate real-world duty cycles and degradation profiles in different segments of the trucking market. LFP offered high cycle life, often quoted in the 2,000-plus full cycles range, and excellent cost and safety characteristics, which is ideal for regional haul operators who run trucks intensively and can live with slightly lower energy density. The NCA and NCM option, with typical cycle life on the order of 800 to 1,500 cycles, traded some longevity for the high specific energy needed to hit a 500-mile range without pushing the tractor's weight over regulatory or payload penalizing thresholds. The pivot in 2026 to high-voltage 4680 cells as the production-ready standard therefore represents more than a simple cell format change. Tesla reports that its 4680 HV architecture for the Semi improves energy efficiency by about 7%, allowing the truck to maintain a 500-mile range while shrinking total pack capacity. In practical terms, higher volumetric and gravimetric energy density translates into hundreds of kilograms, potentially over 1,000 pounds, removed from the pack relative to earlier NCA-based designs. That weight reduction contributes directly to a lower curb weight, with internal targets and external analyses converging around a sub-23,000-pound figure for the tractor, versus previous estimates in the 24,000 to 26,000-pound range. Every pound shaved off the tractor's mass can be reallocated to payload within the 80,000-pound U.S. gross vehicle weight limit, an advantage that fleet operators can monetize immediately in the form of additional freight per trip. How impressive are the Gen 2 upgrades for the 2026 Tesla Semi? Tesla's second-generation Semi design, unveiled at the 2025 annual shareholder meeting, is best understood as a deliberate shift from engineering prototype to a platform optimized for high-volume manufacturing and long-term autonomy. The front fascia now borrows LED headlamp modules from the Model Y and Cybertruck, a choice that is not just aesthetic but economic. Reusing proven lighting assemblies cuts tooling costs, simplifies supply chains, and ensures regulatory compliance in multiple markets. At the same time, Tesla has reduced the windshield's overall area, trimming glass weight while improving aerodynamics. A smaller, more steeply raked windshield reduces frontal drag and can lower cabin cooling loads, which marginally improves real-world efficiency, small gains that compound over millions of fleet miles. The softer, more conventional roofline ties into this aerodynamic strategy. Compared to the sharply faceted prototype shown in 2017, the updated cab profile appears tuned for manufacturability, simpler stampings and fewer compound curves, and for laminar airflow at highway speeds. Beneath the surface, the redesigned chassis is the core of the Gen 2 story. Tesla now targets a curb weight below 23,000 pounds, a meaningful improvement over earlier estimates of 24,000 to 26,000 pounds for the first-generation trucks. For freight operators constrained by the 80,000-pound U.S. gross vehicle weight limit, each ton of tractor weight eliminated is a ton that can be reassigned to payload, directly impacting revenue per trip. Achieving this weight reduction while maintaining a 500-mile range strongly implies deeper integration of the 4680 HV pack structure into the frame, greater use of high-strength steels or alloy stampings, and a more modular underbody designed for automated assembly. Tesla's broader manufacturing playbook, gigacastings, structural battery packs, and highly integrated wiring harnesses, is likely being applied here, even if the company has not disclosed every specific technique, because those are precisely the levers it has used to reduce cost and complexity in its passenger vehicles. A major visible evolution in the Gen 2 Semi is its sensor suite and overall autonomy architecture. Tesla now describes a layout with more than 26 cameras, including units mounted around the front arches and high on the cab, to provide overlapping 360-degree coverage with redundancy in critical zones like blind spots, trailer edges, and merging lanes. This configuration is tailored to the operational realities of Class 8 trucking: long trailers that articulate, tight depot maneuvering, and continuous highway operation where lane changes and merges are frequent. By designing the cab structure, fairings, and mounting points around this dense camera array from the outset, Tesla avoids the compromises and serviceability issues that can arise when autonomy hardware is retrofitted. The electronic and control architecture has reportedly been simplified as well: fewer ECUs, more centralized compute, mirroring Tesla's shift in passenger vehicles to a single powerful FSD computer that handles both driving and many body control functions. That consolidation reduces wiring, cuts points of failure, and improves over-the-air update capability, all key for fleets that demand uptime and predictable maintenance. Aerodynamics remain central to the Semi's economics, and Tesla's Gen 2 updates appear to refine, rather than radically alter, the original strategy. The company continues to cite an energy consumption figure of about 1.7 kilowatt-hour per mile for the long-range variant, suggesting that, while the coefficient of drag may have improved, Tesla is framing those gains as a margin of safety or headroom rather than revising public claims upward. Any drag reduction beyond the already competitive initial design could translate into higher effective range under real-world conditions, or allow Tesla to downsize the pack slightly without sacrificing the headline 500-mile capability. In practice, fleets cares much about consistency, achieving that range in varying weather with different trailer shapes and loads as about the absolute best-case number. Incremental aerodynamic refinements in the cab, fairings, mirror camera pods, and tractor-trailer gap management are likely aimed at tightening that variance band so that route planning and charging schedules can be made more reliable. One of the most strategically important Gen 2 upgrades is the introduction of an electric power takeoff system. Traditionally, refrigerated trailers and other auxiliary equipment rely on separate diesel engines to power their compressors or pumps, adding fuel costs, maintenance complexity, and local emissions even when the truck itself is not moving. Tesla's ePTO, rated up to roughly 25 kilowatts, allows the Semi to supply this power directly from its traction battery, effectively electrifying the entire truck-trailer system. This architecture can eliminate a significant source of idling diesel consumption and noise in logistics hubs, ports, and urban delivery zones, while also simplifying compliance with tightening anti-idling and emissions regulations. Because Tesla controls both the vehicle and the high-voltage power architecture, it can integrate ePTO management into the same software stack that optimizes traction, regen, and charging, ensuring that auxiliary loads are scheduled intelligently so they do not compromise mission-critical range. The Gen 2 design's explicit focus on full self-driving readiness also positions the Semi for a longer technology runway than many competing electric trucks. By hardwiring in substantial sensor redundancy, centralized compute, and a body layout that assumes autonomy hardware will be standard rather than optional, Tesla is effectively front-loading the capital needed for a truck that can evolve via software. In the near term, this means advanced driver assistance features, automatic lane keeping, adaptive cruise and supervised highway driving that reduce driver fatigue and improve safety. Over time, if Tesla succeeds in extending its FSD capabilities to commercial freight corridors, the same hardware could support more automated operation on dedicated lanes or hub-to-hub routes, where the economics of driver time and utilization are most sensitive. For fleet buyers making 10 to 15-year asset decisions, that embedded autonomy roadmap can be as important as the current spec sheet, because it defines how the truck's earning power might improve over its service life. How have partners like DHL and ArcBest validated the Tesla Semi's energy efficiency under real-world operating conditions? Tesla's early customer base for the Semi provides some of the strongest real-world validation that the product is economically and operationally viable at scale, despite a still limited production run. PepsiCo, Tesla's launch partner, has accumulated more than 7.5 million kilometers of operation since 2022, a mileage figure comparable to what a medium-sized regional fleet might log across several diesel tractors over multiple years. Over that distance, Pepsi's reported energy consumption has not only met, but in many cases beaten Tesla's 1.7 kilowatt-hour per mile target, indicating that the efficiency claims from the 2017 reveal are holding up under routine, loaded operation. Pepsi's demonstration of a roughly 1,050-mile 24-hour duty cycle using Tesla's mega charger infrastructure is especially important. It proves that the combination of battery capacity, charge rate, and driver scheduling can support high-utilization freight operations rather than just short, publicity-focused runs. New entrants like DHL further corroborate those performance numbers. After a successful trial, DHL took delivery of its first Semi in December 2025 and reported around 1.72 kilowatt-hour per mile when hauling 75,000 pounds, very close to gross vehicle weight limits and therefore representative of real freight duty. DHL has already signaled that it intends to deploy more than just a handful of units in 2026, and it estimates about 50 metric tons of CO2 emissions avoided per truck per year compared with a modern diesel. For a global logistics provider that reports its emissions to investors and regulators, that kind of per-vehicle impact is material. ArcBest's 3-week trial in July 2025 adds another data point. Over 4,494 miles, the company recorded an even lower average of 1.55 kilowatt-hour per mile, while praising the Semi's ease of use, driver visibility, and comfort. These qualitative factors matter because driver recruitment and retention are major pain points in trucking. A vehicle that is more pleasant and less fatiguing to operate can indirectly reduce labor costs and downtime. Interest from large retailers such as Walmart, Costco, and Cisco, reported as upcoming customers, suggests that the Semi is not a niche experiment confined to a few green-minded brands, but a product being evaluated by some of the largest shippers in North America. These companies operate huge, time-sensitive logistics networks and tend to be conservative about deploying unproven technology. Their willingness to place or consider orders indicates that the Semi's real-world data, particularly from PepsiCo and early freight pilots, has crossed an internal credibility threshold. At the same time, the experience of Ryder Systems highlights the key tension around price. Ryder initially ordered 42 Semis but later cut that to 18, citing significant price increases and changing product economics, and now expects final deliveries around June 20, 26. Industry analysis suggests that while Tesla originally floated a $180,000 price for the 500-mile variant in 2017, actual transaction prices may now be in the $250,000 to $400,000 range, depending on configuration and battery size. This upward drift in capital cost does not necessarily undermine the business case, because the Semi's economic strength lies in substantially lower energy and maintenance costs. At a consumption rate of 1.7 kilowatt-hour per mile and an industrial DC charging price of $0.20 per kilowatt-hour, a reasonable U.S. average for large commercial customers, a Semi's energy cost is about $0.34 per mile. A comparable diesel truck achieving 7 miles per gallon at $4.50 per gallon of fuel incurs roughly $0.64 per mile in fuel cost. The $0.30 per mile spread translates into about $30,000 in annual savings at 100,000 miles per year. So, has Tesla's shift to 4680 batteries genuinely solved the cost and weight problem for electric Class 8 trucks, or has it simply shifted the risk to long-term durability and replacement costs? Please share your opinion in the comments section below this video. Thanks for watching our video. Subscribe now so you don't miss the next breaking Tesla update. It's coming in just 2 days. If you want to explore more exciting information about Tesla EV or Tesla Bot, don't forget to hit the like button and share this video. Also, make sure to turn on notifications so you never miss our latest videos. We appreciate your support and look forward to seeing you in the next video. Goodbye.